let's discuss what is statistics. It is basically a collection of methods for planning experiment, for obtaining data, and then organizing, summarizing, presenting, analyzing, interpreting, and drawing conclusions based on it. Or we can say, in short, statistics is you analyze, organize, and interpret data values in order to improve the process or to minimize the variation. So here these are the basic steps that one needs to follow. First, you have to collect the data about the process that needs to be improved. The second one is organization. Once you collect the data is in raw form. Then you may use one of the tool or the technique to present your data, or data to be presented by using some tables, graphs, or chart, so that a clear picture about the process can comes out. Then once you get the clear picture about the process, then you analyze the data. Here, when you analyze the data, you extract the relevant information about the process that is needed. Then you interpret your result, whether your process needs improvement or not. These are the steps that one generally follow when you are talking about statistical techniques to improve a process or a product. So we can say statistics is concerned with describing, interpretation, and analyzing of data. And here it is an essential element for any improvement process. It can be categorized into descriptive and inferential. And here it uses analytical methods which provide which defines the mathematical model of a system, or it may use graphical methods in order to convey your message more clearly. Once you are talking about analytical methods, that means you are talking about mathematical model, which usually defined in the form of differential equation. Here you perform experimentation, and here with the help of graphical methods, you define your data values in order to communicate about the situation of a present process. Now the word statistics. Statistics is derived from the Latin word status or the Italian word statista. Meaning of these words is political state or government. Here you can find the application of statistics very limited earlier, but um, in earlier time, like rulers and kings needed information about their lands, agriculture, commerce, population, to assess their, why they need the information in order to assess their military potential, their wealth, their taxation, and their other aspects for government. Now let's discuss the need of statistics. Being an industrial engineer, what's the need of studying this basic course of statistics? Here, one of the most important thing in order to find why a process behaves the way it does. If you are operating a process with a defined input variable, and you know that with the help of these variable when you process it, you get the output is defined. But if the output is not as per your requirement, that means there is something going wrong within a process. If something is going wrong within a process, that means that process needs improvement. If process needs improvement, then have to analyze the process. Once you analyze for process analysis, what you need? You need data values. So here to find why a process behaves the way it does. Second one, to find why it produces defective goods or services. When you are manufacturing products or goods, you define your acceptance criteria. Let's say you are manufacturing 1,000 parts for an 8-hour shift. Here, your acceptance criteria is already defined that from 1,000 parts, if 100 parts are of bad quality, that means 10% parts are acceptable to you. But if the case get worst, that means by the end of the day, once you inspect the part, the result comes out that only 600 parts are acceptable, 400 are not as per the requirement. Then you need to find why, what's the reason why process become non-conforming. What's the reason why so many products are defective? Then another thing, center our process on target or nominal. That means there you can find whether your process obtained as per the target value or not. Or you can say in order to check the accuracy or precision of a process, how accurate your process is, or to prevent problem caused by assignable cause of variation. These all problems, the causes you will learn in the next semester in the course metrology and quality control. Reduce variability and improve process capability. If there is a lot of variation in a process, then you have to improve it. That means your process is not capable enough to meet your requirement. So you need to improve the process capability. For that, you need the data values to get the deep understanding about the process. And lastly, to know the truth about the real world. These are some reasons why we need statistics being an engineer. So we can say here the purpose of a statistic is to develop and apply methodology for extracting useful knowledge for both experiments and data. When we are talking about experiments, here we define the mathematical model. When we are talking about the data values, that means here we use graphical measures or numerical measures to define the data. In addition, the fundamental role is in data analysis. Statistical reasoning is also useful in data collection. Here it is defined that's experiments and design of experiments and surveys. That's not the topic for undergraduate student. Here, if you are doing masters or like want to know the course, learn the course in more depth, then you use these techniques in order to define the process, to design the process, and to perform the experiments to get the results and to verify the results. So here the most important thing is to extract useful knowledge, the information that why process need improvement. For that, you use statistical tools and measures. So you can see the application of the statistics. It's been used since the beginning of civilization. Like early empires often collected census of population or recorded the trade in various commodities. The Roman Empire was one of the first states to extensively gather data on the size of empire's population, geographical area, and world. And during the 20th century, several statisticians are active in developing new methods, theories, and application of statistics. Now, these days, here, the availability of electronic computers is basically a major factor in modern development of statistics. Here, why we are saying the electronic computers, because you have predefined applications, you have different softwares, you have different tools where you can define, you can use to these tools, softwares to analyze your data values. These are the statisticians that play an important role in defining the basic tools of statistics. Sir William Patty, and he is the economist who used early statistical methods to analyze demographic data. Now, what is demographic data? It is the study of population based on factors. Which factors? Age, race, and sex. It basically refers to socioeconomic information which expressed statistically, which may include the employment, education, income, marriage rates, birth and death rates, and several factors. Now, Sir Carl Friedrich Gauss, he developed the methods of least square. Least square is basically used in the regression, where you find the best fit. Let's say here, this is the plot. Here you define, here you have two variables x and y, dependent variable and independent variable. And here you find the relation between these two values. With the help of least square method, you can find the best fit line and the equation to define the relation between independent and dependent variable. Like what does this method do? With the help of this method, you can define the best fit line, which defines from where you get the mathematical relation about your process. And here you can define the relation between these two variables. The next is Ronald Fisher. He is the one who single-handedly created the foundation of modern statistical science, like different tools and techniques, the data, the way we define the data numerically. These tools are defined by him. Now, James Lind, he carried out first ever clinical trial and show an effort to find a treatment of scurvy, the disease. If you want to find the application areas, you can find the application everywhere. If you want to predict the disease, like here it is written that 85 to 90% chances of lung cancer are smoking related. That means the statistics tell you that almost all lung cancers are related to smoking. And if you want to have good chance of avoiding lung cancer, you should smoke. It is also applicable in weather forecasting, where you define the situation on the basis of probability. And here it is used in medical studies which show statistically valid rate of effectiveness before any drug can be described. Then you can find whether the test that you conduct before introducing the drug to the market has passed or not. It is also useful in quality testing. As you all know that the companies make thousands of products every day, and every company, each and every one have to make sure the quality of product. Why? Because in order to capture the market, we all know that it is impossible to test each and every item. So the company uses statistics to test few items, which is called as sample, and on the basis of that result, we define whether the product quality is good or not. And in the same way, stock market is the topic that you hear a lot in the news. In the is the stock market. It is also uses statistical computer models to forecast what is happening in the economy. Now, we already discussed that statistics is basically science of data where we collect, classify, summarize, organize, analyze, and interpret data values. For data collection, we need to define some tools. So, here, statistics. It may be descriptive or inferential. When you are talking about descriptive statistics, it is basically method of describing the characteristic of a data set. Which method you are using, it is useful because it allows you to make sense of a data, and here you explore and make conclusion about data in order to make the decision. It also include calculating things like the average, the spread, the shape, or we can say, like for example, if you want to know the weight of a product in a production line or the time taken to process an application. That means you need some tool to find out the relevant data values. And once you find the data values, then again you need some measures to define your data. And you collect the data values when you define the measures, the information. That means you are talking about descriptive statistics, which basically involve describing, summarizing, and organizing data so that it can be easily understood. So here graphical displays are often used along with quantitative measures. Why? In order to in order to enable the clarity of communication, so that it will be easier for everyone to communicate the given situation. So when analyzing a graphical display, you can draw different conclusions based on several characteristics. Like you may ask questions such as where is the approximate middle or the center of the graph, how is spread out the data values, what is the overall shape of the graph, does it have any interesting factors. So these are the some graphical displays or tools that you okay use. And these you cover in the portion describing data numerically. That's your course learning outcome number one, where you get basic knowledge about the course, which is linked to the program learning outcome engineering knowledge. Here you should at least know how what are the measures that you can use to define your data. If you want to find the measures of central tendency, that means you're finding whether your process meets the target value or not. Then you may use measures of variation. It tells about the variation or the deviation from the mean. Or here you may define the shape of the distribution you are analyzing, and this one is also quartiles, where you can split the data values into four equal parts. These now in descriptive statistics, we learn that it involves describing, summarizing, and organizing the data. Once you organize the data, then you use these data values to draw conclusions. To draw conclusions about population. So the branch of statistics that analyze sample data to draw conclusion about population is inferential statistics. That means let's discuss the term population. What is population? If you are talking about um, a complete set, that means a complete set of data element is called as population. When I'm talking about a class of 70 students, that means I'm talking about population. And the subset of population is called as sample. When I'm talking about the top 10 students, that means I am talking about a sample. And the The two important terms that you need to know: parameter and statistic. Now, population is complete set of data element. Sample is the subset of population. And what is parameter? Parameter is basically any numerical value that describe the characteristic of population. And what is statistic? Any numerical value that describe the characteristic of a sample. That's the There is a difference between statistics and statistic. Statistics is the science of data, and statistic is basically a numerical value or measure that defines the characteristic of a sample, or we can say that characterize the sample. Like, let's take an example. This is the population. If you want to find the average, let's say we have 50 students in a class. We conduct a test which is of 10 marks, and if you want to find the average marks, then what we do, we add all the 50 scores and divide the total by the total number of scores. That means total number of students are 50. Add the total scores and divide by total number of students, we get the population mean, and population mean is represented by mu. Now, if you draw a sample of 10 students, if you randomly pick 10 students, and if you want to find out the average value with respect to sample, what you do, you add 10 values and divide it by 10. Here you find sample mean, which is represented by x bar. So it is a numerical value which is used to define population, and this numerical value is called as parameter. And it is a numerical value which is used to define sample, and this numerical value is called as statistic. So this is a population, this is a sample. What's the need of doing sampling? It is impossible to analyze each and every data values. Let's say if a company manufacture 500 products for 8 hours of operation, then by the end of the day, before shipment to the customer, you have to verify whether the product is made as per the requirement of customer or not. Then it will be difficult to check 800 parts. What you do, you apply sampling technique to draw some parts randomly. Let's say you draw two samples. Sample number 1, which is S1, sample number 2, which is S2. You have a population which is of size 800. Here, sample size number 1 is 10. Sample size number 2 is also 10. That means from 800 parts, you randomly draw 20 parts. You inspect these 20 parts, record the results, and let's say you have to find the average. When you find the average of sample number 1, it is x1 bar. When you find the average of sample number 2, it is x2 bar. These values are described the sample numerically. These are called as statistics, and you use this information. With the help of this information, you take a decision about a population, whether the population is acceptable or not. Here, what you do, you collect the data, you organize the data, and you interpret the data. And when you interpret the results, you draw conclusions about population. Here, once you draw conclusions about population using sample knowledge, then this is called as inferential statistic. And in descriptive statistic, what you collect the data values to find the values that are important with respect or analysis. And here you find these two values. These values describe the samples numerically. That's why they are sample statistics. And if you want to find the sample, you can say the estimated population mean, you can find it by using x1 plus x2 bar divided by 2. You can say it is approximately equals to the population mean. So population is the complete set of data element. The subset of population is called as sample. The numerical value which defines the characteristic of a sample or describe data numerically for sample is statistic, and any numerical value that describing the population is parameter. So here that's the difference between statistic and parameter. These are the sample statistics: x bar sample mean, population parameter mu, sample standard deviation s, population standard deviation sigma, proportion p bar, proportion p, sample size small case n, sample size cap uppercase n. So these are the numerical measures which defines or characterize population. They are parameters, and these are the numerical measures which characterize the sample, and they are statistic. Hope you get the basic introduction. Then what we are going to cover in this course. Here we discuss the basic tools and the techniques to define the data numerically. Then we learn how to apply different probability distributions. Then we also learn how to define the relation between the two variables in order to define the mathematical model.